All right, pattern number 3. Okay, this one is called a proton transfer. It's actually an acid-base reaction. We have an acid, we have a base, and form a reaction. All right, so we have an acid, we have a base, and the base, of course, got the lone pair. Right, we learned in this chapter 3, and so you can draw. That's your nucleophile, and the electrophile is the proton. All right, so we draw the nucleophile. So atom to atom, or more specifically, the lone pair of that the nucleophile to the atom of in the electrophilic center. All right, use this arrow to break this bond, go become a lone pair on oxygen, and you get that. All right, the proton transfer is actually a nucleophilic attack on the proton. There's a nucleophilic attack on the proton, and the nucleophile is called a base. It's an acid-base reaction. Right? Looking down right here, so you can see this guy is a base or the nucleophile, like electron rich right here, negatively charged. Right? And the proton is right here. All right. So draw from start from at nucleophile, attack an electrophile, and this bond breaks. You get a negative charge on this carbon, and hydroxide gets one more proton, become water. Okay. All right. Down here, so who's the nucleophile, or who's the base? Looks like alkene. This alkene gets the proton, proton from hydrochloric acid. So we have a base here. This is your nucleophile, and the electrophile is that proton. All right. So you attack, and this lone pair, not lone pair. The bond, this bond become a lone pair on chlorine. So we draw from bond to chlorine. All right. So you get 4 lone pairs at the end. Okay. Right, and now look at the whole mechanism here. So how many proton transfer are there? Take your time, pause the video right here, no rush at all, right? There are multiples of them. All right, let's take a look which step has a nucleophile attack a proton, right? First step for sure, this is hydronium ion, an acid-base reaction. An acid and nitrogen gets the proton. This act as a base. Okay, so this proton transfer. Number 1, nucleophile attack. Nope, it's not. Yep, another one right here. So we have the second one right here. Water acts as a base, grab proton. This guy acts as an acid, right? This guy kind of look like a hydronium ion. Take a look. Oxygen with 3 hydrogen. That so oxygen with 3 hydrogen, just like the hydronium ion. Okay, so water acts as a base. That's the proton. What else? Another hydronium ion. See that? So third step right there, third proton transfer. This nitrogen, the lone pair on nitrogen, act as a base, and this guy's an acid. Do we have one more? The last one. Yes, this one right here. This is also a proton transfer, right? So oxygen with 3 bonds, so 1, 2, and 3. You probably think that doesn't look like that. Well, actually, it's kind of look like the hydronium ion. So oxygen with 3 bonds, 1, 2, and 3. This is the last proton there, right? Water act as a base, attack a proton, and this lone pair, bond right here become a lone pair on oxygen. Okay, so there are 4 proton transfers here. All right. All right. Which one is nucleophilic attack? Do we have nucleophilic attack? A nucleophile attack a non-hydrogen atom, right? If a nucleophile attack on hydrogen, we call proton transfer. If the nucleophile attack something else, none other hydrogen, that's a nucleophilic attack. And we have one right there. That's a nucleophilic attack. Oxygen attack that carbon. Okay. What else do we have? There's one loss of living group here. Can you tell which one? Right here, this is the loss of living group. All right. Now the living group is that nitrogen with the positive charge. Yeah, positively charged nitrogen leave this molecule right here. Some of you think that, hey, hold on, it doesn't actually leave. Nitrogen is still there, still in the molecule. Well, that's because of this nitrogen bond to this molecule with 2 bonds. We break 1 bond. If this nitrogen doesn't have the other bond right here, it probably would have left the molecule. Right, this is a cyclic compound. Okay, but this bond is actually break. Right, so nitrogen leave that carbon. Okay, so there's a loss of living group. Ta-da! All right, one more. The last pattern.